Hello, my name is Nilesh. In this video, we are going to see how to use Kubernetes namespaces. Namespaces has been there for a quite long time in mainstream programming languages like .NET, Java, Go, and all other programming languages. They allow us to group resources together in logical manner, and similar concept applies to Kubernetes as well. So let's deep dive into this video and see how we can use the namespaces. This video is continuation of the Cloud Native Ninja series where we have done already 12 parts of the series. If you have not seen the earlier videos, I recommend that you go and watch the earlier parts of this series. In this video, we will focus our energy on Kubernetes namespaces. What is a Kubernetes namespace? In Kubernetes, if you look at the documentation in the kubernetes.io docs, it says that a namespace provides a mechanism for isolating the resources within a single cluster. In most cases, we have a cluster which is shared by multiple teams, and we want to make sure that the resources which are used by one team, they are not overridden or other team doesn't override those resources. And that is one of the benefit of using the namespace. Let's go and see how to make use of namespaces in Kubernetes. I'll head over to the terminal and start using the kubectl command. Now, if I go and do this kubectl get pods to list the number of pods which are running, we see that on this particular cluster, there are no namespaces or there are no resources which are running in the default namespace. Where does this default namespace come from? If we run this command, which is kubectl get namespace or namespaces, both of them will result in the same output. And we see here that there are 4 namespaces which are created by default. When we create a Kubernetes cluster, the Kubernetes will create these 4 namespaces for us. There is a default namespace which is created. Then there is the kube node lease, there is kube public and kube system. If you want to find out what are the different resources under each of these namespaces, we can then run this command kubectl get, let's say, pods, and we can specify the namespace with -n in the short form or -- namespace in the long form parameter. And let's say we want to find out which are the resources which are there in the kube public namespace, or we are interested in finding out which are the pods which are running in kube public namespace, and we don't find any resource there. Let's look at the kube system and if there are any pods in the kube system namespace. And here we can see a big list of pods which are running. So these are the default pods again which are created by Kubernetes, and these are required for running the Kubernetes system resources. We see things like Azure IP, Mask Agent is running, Cloud Node Manager, we have the core DNS, the CSI Azure Disk, and various other pods which are part of this. If we want to list all the resources, we can use the kubectl get all command, and then for listing all the resources under all namespaces, we can give all and namespaces as the parameter. And here we can see a big list of items which are part of all the namespaces. So as we saw in the kube system, there are this list of pods. Then kube system namespace also has the services. There are daemon sets running, there are deployments, and there are replica sets running. Now, if we want to create a namespace for our own application, there are multiple ways in which we can create it. Previously on this channel, I have created a video to show how you can use imperative commands, which are like you run the command on the command line itself and it will create Kubernetes resources for us. So if we use the imperative command to create a namespace, then we can create namespace using this kubectl create namespace command, and then give the name for our namespace or custom or the application specific namespace that we want to create. I want to create, let's say, TechTalks, and as a convention I want to have ns in there to identify that it's a namespace type of an object. And we see that it is creating this TechTalks ns as the namespace. Now if I run the kubectl, I have the alias, so I'll just use k going forward. So k get, and if I use the short form again for namespaces as ns, we see that 14 seconds ago, the TechTalks NS has been added to the 4 default namespaces which were created. So it's very easy to create the namespace using the imperative command. Now let's switch back to Visual Studio Code and list some of these things. We looked at some of these commands, like how to get all the namespaces or all the objects in all the namespaces. We can even filter for specific objects, like we can run kubectl get pods, get services, get deployments, and the permutations and combinations of this can be run. We can even filter it out for specific namespace, which we saw earlier. We looked at how to create a namespace using imperative command. Now let's go and see how we can create a resource for our application within this namespace. First, we will look at again the imperative approach, and in here I am at the location or in the directory structure where I have got multiple manifest files for my application, which is the TechTalks application. We have the TechTalks producer, which has producer, deployment, and service, and there is TechTalks consumer, which has a Go version of the consumer deployment in manifest file. So I'll be using this files or these Kubernetes manifest for this particular demo. Let's see how we can apply the namespace and how we can create the producer, deployment, and service within that namespace. So I'm going to run this kubectl apply command, and I want to run it recursively for all the files which are part of the TechTalks producer. And as we saw earlier, there are two files, the TechTalks producer deployment and the TechTalks producer service. And since we are providing the TechTalks NS as the namespace parameter on the command line, now if we go and run the command to filter out the resources for this, we should be able to get those. So let's run kget all, and then we give the namespace as TechTalks NS. So we can see here that there are 3 pods because I have the count as replica count as 3 for that particular deployment. It is running 3 pods of the TechTalks producer or RabbitMQ producer as it is named here. And there is a RabbitMQ producer service which is created, and there is also a replica. And all these are part of the TechTalks namespace or TechTalks NS namespace. Now let's go and see the other approach which can be used to create in a declarative way. I can create the same namespace using the manifest file and provide these details. With the API version as 1.1 and kind as namespace, I can specify the metadata to say that the name that I want to create for my namespace is TechTalks NS, and the label that I want to assign with this is TechTalks NS. So let's go and try this approach. I'm going to delete the namespace TechTalks NS, and it will delete all the resources as well which are part of that namespace. So if we do after this deletion is completed, if we run the command again, which is kget all, and then we give all namespaces, we will see that the namespace TechTalks NS would have been deleted, and also the resources which were part of that namespace, those the replica set, the deployment, and the service and the pods which were created for TechTalks producer, all has been deleted as part of deletion of the namespace. Now let's look at how we can apply this particular file, which is for creation of the namespace in the declarative way. So in the namespace folder, I have TechTalks-namespace.yaml file, and I can run the kubectl apply command with file as the reference to this file. And with that, we have the namespace created again, TechTalks namespace. So this is alternative approach. If you don't like the imperative command, which is typing out the whole command on the terminal, if you want to put all your resources in like source control, it could be Git repository or something like GitHub hosted one, or your internal GitLab kind of repositories. You can use this YAML based approach, where declaratively we specify what is the metadata which is required for creating of the namespace. Now once the namespace is created, the second approach, instead of specifying the namespace as a parameter on the creation of the objects, let's look at how we can embed this as part of the declarative syntax itself. Here I have the RabbitMQ consumer deployment, and in the metadata, if you see on line number 6, we have this namespace attribute or property, and here we can specify the namespace name, which in our case is TechTalks NS. So I'm going to apply this to the file, and let's see what happens. So here I'm running kubectl apply command. It could also be kubectl create. Then we pass the file name, which is the consumer deployment -go.yaml. And now if we run kget all and we specify the namespace as TechTalks NS, we will see that the RabbitMQ consumer deployment has been created as part of that declarative syntax. So these are the different ways in which we can work with the namespaces. What is the use of creating a namespace? Namespace is very basic object. It comes as part of the Kubernetes built-in APIs, and some of the benefits of using namespaces is first one is resource isolation. We can isolate resources such as the pods, services, volumes, etc., and ensure that one application resources, they are organized in a logical manner, and they are isolated for that particular application. Let's say one service is used by, or two different applications has the same service name, like customer service, for example, as in just a hypothetical case. And if one application goes and deploys customer service in the Kubernetes cluster, and this cluster is shared by multiple teams, and then the next application comes and deploys another version of the customer service with a different definition altogether, it will override what the first team did. So in such cases, in a multi-tenant environment, it is very important to isolate the resources which are required for a particular team, and namespaces is one way of doing that. The second thing is to organize the resources. This is for managing the resources in an efficient manner. Now, when we have multiple resources deployed, it would be logical to have these resources clubbed together based on the needs. In most cases, we have resources which are, or namespaces which are created by, let's say, monitoring. For example, if you have services like Elasticsearch running Prometheus, Grafana, and you have Jaeger, these kind of things which are related for making your applications resilient and bringing in observability, we can create a namespace for these infrastructure kind of resources, the monitoring and observability related resources, and put them together. Then the applications can reside in application specific resources. So it helps us to organize resources and to manage those resources efficiently, instead of having everything in the default namespace. By organizing them into logical namespaces, it gives us the opportunity to manage these things in a better way. The next use case where we can use namespaces is to have resource constraints and resource limitations by means of having resource quotas. So in Kubernetes, there is this concept of allocating resources and assigning resources by means of specifying a quota for CPU, memory, and other resources. This allows us to have better utilization of the cluster. We can ensure that one team is not hogging all the resources of the cluster. We can have policies in place to make sure that most of the teams, they use a similar kind of resources as per their needs, and only when there is a need to change the resource allocation, we can go ahead and update them. So this ensures a fair distribution of resources across multiple teams. The other use case which I've seen quite common is for using dev and testing environments on the same cluster. Usually you will separate a cluster from lower environments and production. Production will have a dedicated Kubernetes cluster, but the lower environments like the dev cluster, UAT, SIT, these kind of cluster or these kind of environments are hosted on the same cluster. And the first case where I was talking about resource isolation and resource organization, where one team steps onto the resources of others team, this can be eliminated by having resources which are namespace based on the environment. and this helps to also organize things like based on your environment, all resources for that environment can reside in the same namespace. Here are some of the best practices when we are dealing with namespaces. Logical separation is the first one, where we can create resources and put them in logical units. This can be based on the environment, it can be based on teams, it can be based on the type of applications. Say for example, we are having normal cloud native applications, and then there are things like the GPU based applications, for example. So we can have different namespaces for these kind of requirements. The second thing which is related to the best practice is to limit the namespace scope. We want to make sure that just the right number of resources are there in a particular namespace. We don't want to overload it with too many objects and services and resources. This could lead to performance and management problems if we put too many resources in one namespace. Resource quota is another use case where when we are dealing with the namespaces, we can define a standard policy for defining the resource limits and make sure that teams are not over utilizing their resources. This ensures that there is a fair distribution of resources and the overall cluster, when it is in a shared environment, is used effectively by different teams. Standardizing the names and conventions is another best practice to make sure that all teams follow a similar convention. And when we have a large cluster, it becomes easier to manage it if we follow standard naming conventions and guidelines. I've put some examples here, like we can have the environment name, then the type of the workload, and then the application, like the UAT apps is for application specific namespaces, and then app1 is an example of a specific application related namespace. Similarly, we can club together monitoring resources by using environment name like UAT, then monitoring, and the namespace related to all monitoring resources, and so on and so forth for dev and other clusters or other environments. Namespaces also allows us to have role-based policies. This ensures that the right person with the least amount of privileges has the right permissions to create, to update, delete, and delete resources for their application. Assume that there are two applications running, and one application team tries to update the resources for other application team. This is a no-no scenario, or this is something that should be avoided in real life. So namespaces allows us to have this role-based access to make sure that one team has access only to the resources which are specific to their application, and they cannot perform other operations on the other resources of other teams. The next best practice is to use labels and annotations. This is from the management point of view, where we want to automate things, and when we want to discover things, things like annotations and labels, they help us to add metadata to our namespaces and the resources associated with that namespaces. So it becomes easier to find, locate, and search for resources using things like labels and annotations. From a housekeeping point of view, we should also implement a namespace cleanup. When namespaces are not required, if we don't have any resources running in the namespace, it is better to have some automation which cleans up these orphan namespaces, or namespaces with zero resources, or namespaces which are no longer required for a particular application in a bigger cluster. We should also monitor and log the resource usage and track the resources. This can help us to make sure that we have the right security and performance related capabilities in our cluster. If we set the limits on let's say our resources using resource quotas, when the resource quota gets utilized up to, let's say, 70 or 80%, we can have notifications in place to make sure that the application owners or the team who is running that application knows that their resources are approaching their limits, and they are not hit by a scenario where, let's say, there is auto scaling enabled and they try to go beyond the limits of their namespace and they cannot create more resources. So in this kind of scenarios, monitoring helps the application teams to be more proactive and to respond to potential issues which could happen in future. And from a backup and disaster recovery point of view, there are solutions available which allows us to back up the namespace and the resource related metadata into the backup solution. So this again helps us in recovering the application faster if we have to recreate similar environment, similar resources on a different Kubernetes cluster. So that brings us to the end of this video. This is again part of the Cloud Native Ninja series that I've been doing for some time. And you can go through this GitHub repository to understand what are the different features which are part of this Cloud Native Ninja series. All the commands that I ran during this demo are available as part of a markdown file in the docs section of the repository, and the slides are published to SlideShare and SpeakerDeck. I hope you found this useful. In case you find this content useful, please hit the like button, subscribe to the channel, and share it with your friends. Until next time, code with passion and strive for excellence. And in case you have any suggestions, feel free to put them in the comments. Thanks once again for watching this.